Dear students and other viewers, today we will discuss the empirical relationship between mean, median and mode. This relationship has been explained by Carl Pearson. First we will learn graphically with the help of diagram the relationship between these three statistical tools, that is mean, median and mode, and that is based on given frequency distribution. Number one is, if the frequency distribution is normal, we can write symmetrical frequency distribution. Symmetrical frequency distribution. Or we can write for this normal frequency distribution. If there is normal frequency given in the data, then value of mean, median and mode will be same. In this case, value of arithmetic mean denoted by x bar and median, value of median and value of mode all will be same. Mode denoted by letter Z. In this case, that is case of normal frequency distribution, also known as symmetrical frequency distribution, the value of mean, median and mode will be same. In this case, the shape of frequency curve is bell-shaped. On vertical axis, we take the values of frequency f, notes frequency, and on horizontal axis the values of variable, generally denoted by x. X is a variable and f is a frequency. And in case of symmetrical frequency distribution or normal frequency distribution, the shape of frequency curve is बेल शेप्ड. इसमें जो शेप ऑफ फ्रीक्वेंसी कर्व है वो बेल शेप्ड है, like this. This is the frequency curve, bell shaped frequency curve, and this is the point, highest point of frequency curve, showing the highest frequency of the given variable, because this on vertical axis shows the value of frequency, and in this case this point shows this point, shows the value of arithmetic mean denoted x bar and value of median and value of mode denoted by letter Z will be same. इसमें हर एक का वैल्यू बराबर होगा और जो शेप ऑफ कर्व है वो है बेल शेप्ड. As you know that mode is that value of variable which is having highest frequency. This will be the highest point on frequency curve, and median will be the middle value of given frequency distribution, or we can say middle value of given statistical data, and arithmetic mean gives the average value of a given data. In this case, their value will be same. Second case may be asymmetrical frequency distribution. Asymmetrical frequency distribution. In this case, there is much variation in the given frequency. In asymmetrical frequency distribution, there are two cases. Number one, or we can write a part positively skewed frequency distribution. In this case, value of arithmetic mean and median will be greater than value of mode. Arithmetic mean, it will be greater than value of median and value of mode. In this case, this is the relationship between arithmetic mean, median, mode. Arithmetic mean, median and mode. And the shape of frequency curve is like this. The shape of frequency curve will be like this. On vertical axis, the values of frequency, f is frequency, and on horizontal axis, value of variable, and the variable generally denoted by x. It may be any variable. And this will be the shape of frequency curve. This is the frequency curve drawn on the base of given frequency of a variable. This will be the highest point on frequency curve that shows the value of mode, and this will be the central point of this frequency curve that gives the middle value, that in other words, value of median. I will denote median by m. Consider it is the median, and this point shows the value of arithmetic mean, x bar. In this case, value of mode, it will be less than median, and median will be less than value of arithmetic mean, or in other words, arithmetic mean will be greater than median, that will be greater than value of mode. Because as we move from this point towards this direction, it shows the highest value of the variable. As it lies on the right side of these, therefore the value of arithmetic mean will be greater than the value of median and mode. Now, one more case of asymmetrical frequency distribution is negatively skewed frequency distribution. Negatively skewed frequency distribution. If frequency distribution is not normal and it is negatively skewed frequency distribution, then value of mode will be greater than value of median and arithmetic mean. Or in other words, we can write value of arithmetic mean will be less than value of median, and that will be less than value of mode. Mean x bar and mode denoted by z. Or in other words, mode will be greater than median and arithmetic mean. And the shape of frequency curve will be like this. On vertical axis frequency, on horizontal axis value of variable. This will be the shape of frequency curve. This will be the highest frequency, highest point on frequency curve, showing the value of mode. This will be the median, M median, and this will be the value of arithmetic mean. In this case, the arithmetic mean, it will be less than median, that will be less than mode. Or in other words, value of mode will be greater than median and arithmetic mean. Median M. X bar is arithmetic mean, M is median, and Z is mode. In this case, you will remember that the value of mode is always greater than the value of median and arithmetic mean if the frequency of a given data is negatively skewed. That is negatively skewed frequency distribution curve. This is the frequency curve. Now we can also show the relationship between mean, median and mode with the help of empirical formula. This was how we can show relationship between mean, median and mode with the help of graph, with the help of diagram. There are two formulas and both will give the same result. Number one, mode is equal to 3 median minus 2 mean. 2 mean x bar. And second formula is mean minus mode is equal to 3 times the difference between mean and median. arithmetic mean denoted by x bar, mode by z, 3 times mean by x bar, and median For example, if the data is given, if statistical information is given, the values of mean, median is given, and you have to find out the value of mode, you can apply any of these formula. Or if the value of mode and mean is given, you have to find out value of median, you can apply this formula, any of these two formulas to get the result. For example, the data given is arithmetic mean is equal to 25, mode is given equal to 10, and you have to find out median. You have to find out the value of median. First we will apply this formula. Mode is equal to 3 median minus 2 mean. Mode is given equal to 10. We have to find out the value of median, 3 median, and in place of arithmetic mean we put the value equal to 10. 2 into value of arithmetic mean, that is 10. 10 will be equal to 3 median minus, the value of arithmetic mean is given as 25. 50. Mode will be equal to, 10 will be equal to 3 median minus 50. 3 median will be equal to 60, and median will be equal to 60 divided by 3, it will be equal to 20. Now we will apply the second formula to know whether we will get the same result or not. Mean minus mode is equal to 3 times the difference between mean and median. X bar z 3 times arithmetic mean minus median. Value of arithmetic mean, it is given equal to 25. Value of mode, it is given equal to 10. Value of arithmetic mean, it is given equal to 25 minus, we have to find out the value of median. 25 minus 10, it will be equal to 15. It's equal to 3 5 15, 3 to 6 75 minus median. Minus 3 median. 3 into 25, it will be equal to 75 minus 3 median. It will be equal to 3 median will be equal to 60. Median will be equal to 60 divided by 3, that is equal to 20. Applying this formula, mode is equal to 3 median minus 2 mean. We have got the value of median equal to 20, or by applying this formula, mean minus mode is equal to 3 mean minus 3 median. In this case, we have also got the value of median equal to 20. Whether we will apply this formula or this formula, we will get the same result. This was the how we get the value of any statistical tool such as mean, median and mode by showing their relationship with the help of these formulas. And this was how we will show the relationship between mean, median and mode with the help of graph or with the help of diagram and with the help of these formulas. I hope you have got it and you can do more examples using these two formulas. Thanks.